Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Today I will discuss a problem from an audience, and I will put this video into a new playlist. In the future, I will put all problems from audience into that playlist. So welcome to send me your questions or doubts. Let's see the problem. ABCD is a cyclic quadrilateral with sidelines as follows. AB equals to 6 cm, BC equals to 12 centimeter, CD equals to 3 centimeter, DA equals to 6 centimeter. Right, so let's just draw it first. We know that ABCD is a cyclic quadrilateral, but it's difficult to draw the plot very accurate by hand, right? I'll just try my best. This is BC, and we use half of BC. So because BC is 12 centimeter, right? And we know that AB and DA are 6 centimeter, so that's half, right? And CD is 3 centimeters, that's half of the, quarter of the BC. So roughly say it looks like this, right? So BC is 12, AB is 6, AD is 6, and DC is 3. Let the intersection of AB and CD be E. So intersection of AB and CD be E. So this is E. And the intersection CB and AD be F. Right, so this point is F. Find the length EF. Okay, so for this problem, I discussed with the audience, and we actually find two solutions. But when I prepare this video, I find the third one. I believe that the third one is the simplest solution. The audience asked for he or she has a solution, but want me to find an elegant one. I feel that the third one may be the shortest. I'm not sure if that fits the definition of elegant, but let's just discuss about this. So first I'll talk about the solutions that I figured out at first, right? If we look at the problem set that ABCD is a cyclic quadrilateral, which is very important information, right? Because that gives us the following angle relation, that angle EAD equals to angle ECB, right? This angle equals to this angle. And angle EDA equals to angle EBC. This angle equals to this angle, right? We know that angle AED equals to angle CEB. So we got EAD, triangle EAD is similar to triangle ECB. Right. And look at this angle. angle FDC equals to this angle equals to angle FBA, and angle FCD equals to angle FAB, which means triangle FCD is similar to triangle FAB, right? So from first one, from the first triangle two triangle similarity, we can get that EA to EC, which is EA to EC, right? Which is ED plus DC equals to AD to BC, right? EA to EC. EA to EC equals to AD to BC, which is 1, 2, 2, right? 6, 2, 12, that's 1, 2, 2. And we have ED to EB, which is EA plus AB equals to AD to BC, right? Again, it's 1, 2, 2. Right, so from this one, we have that 2EA equals to ED plus DC, which is 3, right? 3 centimeter. And from this one, we have ED equals to 2ED equals to EA plus AB, which is 6, right? So from this, we got that ED equals to 2EA minus 3, right? So 2ED, that is 4EA minus 6 equals to EA plus 6. So we got EA equals to 12 divided by 3, that's 4, right? And based on this is 4, that's 8. So 8 minus 3, that's ED. So we got ED equals to 5. And from this one, that triangle FCD is similar to triangle FAB. We have FC to FA, which is FD plus AD. So FD plus AD equals to DC to AB, which is 3 to 6. That's 1 by 2. And FD to FB, which is FC plus BC, equals to 1 by 2, right? 3 to DC to AB, that's 3 to 6, 1 by 2. So from that, we have 2FC equals to FD plus AD. AD is 6, right? And 2FD equals to FC plus BC. BC is 12. Look at these two sides of the equations, right? This absolute number just 2 times in the second side, so which we can directly calculate that FC. So FC would be twice of EA, right? EA is 4, so FC equals to 8. FD would be twice of ED. ED is 5, so FD equals to 10, right? So let's see. AE is 4, and ED is 5, right? DF is 10. And FC is 8. Right? So now we connect AC. AD, the ratio of AD to DC equals to 623 equals to 2, which equals to FD to ED, right? And the angle ADC equals to angle EDF or FDE. So we know that triangle ADC is similar to triangle FDE. Right? So we want to know the length of AC. Based on this one, the triangle ADC is similar to triangle FDE. We know that angle CAD equals to angle EFD, right? This angle CAD, this one, equals to this one. So we know that AC is in parallel with EF, right? And if we know the length of AC, then we would easily know the length of EF because AC is in parallel with EF and we already know the ratio, right? So how can we calculate AC? We can do this because A, B, C, D. Look at the quadrilateral A, B, C, D, right? So because A, B, C, D is a cyclic quadrilateral, right? So the angle ABC plus angle ADC equals to 180 degree, right? Then we can use cosine rule that for the triangle ABC and triangle ADC, we have that AC square equals to AB square plus BC square minus 2AB BC cosine angle ABC, right? Also AC square equals to AD square plus DC square plus let me write minus first, minus 2 AD DC cosine angle ADC, right? Because angle ABC plus angle ADC equals to 180 degree, so we know that this can be rewritten as AD square plus DC square plus 2AD DC cosine angle ABC, right? So from these two, we have that AB square. So I'll just replace the number here. 6 square plus BC square, that's 12 square minus 2 times 6 times 12 times cosine angle ABC equals to AD square, which is 6 square plus DC square, that's 3 square plus 2 times 6 times 3 times cosine angle ABC, right? So we know that 12 square minus 3 square equals 2 times 6 times 15 times cosine angle ABC, right? And this equals to 12 plus 3 times 12 minus 3, right? So that's 15 times 9 equals to 2 times 6 times cosine angle ABC. So we know that cosine angle ABC equals to 9 by 12, which is 3 by 4, right? So based on this one, we can calculate for AC, right? AC square equals to AB square, which is 6 square plus 12 square minus 2 times 6 times 12 times 3 by 4, right? It equals to 36 plus 12 squared, that's 144, minus 12 times 12, that's still 144 times 3 by 4, right? So 144 divided by 4, that is 36, times 3, that's 108. So it equals to 180 minus 108, so it equals to 72, right? That's AC squared. So we know that AC equals to 6 square 2, right? And based on this, we know that AC to EF equals to BC to BF equals to 12 to 20. So EF equals to AC times 20 by 12 equals to 6 square 2 times 5 by 3, right? That's 10 square 2. Okay, that's the length of EF. That's the first method of this problem, and let's look at the second method. Okay, so I draw this figure again here. That's BC, right? And right, that's A, this is D. So this point is E, and this is F. Okay, for the second problem, for the second solution, that we already know A, B, C, D is a cyclic quadrilateral. Let me mark the length here. Right, so that means EA times EB equals to ED times EC, right? Because ABCD is a cyclic quadrilateral, which means we can rewrite this as EA times EB, which is EA plus AB, equals to ED times EC, that is ED plus DC. Right. And notice that AB equals to AD. That means if we connect AC, the angle ACB equals to angle ACD, right? Because the chord are equal. So we know that AC is the angle bisector of angle BCE. Then we have BC to CE equals to AB to AE, right? So we write this one here, EA times BC, right? Equals to AB times CE. CE is ED plus DC. Right, so EA is an unknown variable, right? So we can represent EA to be AB to BC times ED plus DC, which equals to 1 by 2, right? AB to BC times ED plus DC is 3, right? And we replace EA by this one, so we have half of ED plus 3 times half of ED plus 3 plus AB, which is 6, right, equals to ED times ED plus 3, right? So we can cancel this out, right? Then we got 1/4 of ED plus 3 plus 3 equals 2 ED. So we know that 3/4 of ED equals 2. $15, right? That's 12 plus 3, 15 by 4. So we got ED equals to 5, right? ED equals to 5. And we know that EA equals to this one. So EA equals to 1 by 2 times 8 equals to 4, right? And now we can use Mendeley's theorem for the triangle EBC and the intersection line ADF, so that we have EA to AB times BF to CF times CD to DE equals to 1, right? And BF to CF can be, so EA to AB, we already know the length of EA, that is 4, to AB is 6, times BF is 12 plus CF to CF times CD to DE. CD is 3 and the D is 5, so 3 to 5 equals to 1, which means 48 plus, so let's just simplify this one. So 24 plus 2CF equals to 5CF. So we know that CF equals to 8. Right? CF equals to 8. So based on what we have here, because we already know the length of AE, the length of EC, the length of AC, right? Oh, actually here this AE equals to 4 and ED equals to 5. Yeah, so basically we know for the triangle AED, we know the 3 lengths. So we can calculate angle, cosine angle EAD, right? That is ED squared equals to EA squared plus AD squared minus twice of EA times AD times cosine angle EAD, right? So ED squared is 25 equals to EA squared, that is 16 plus AD squared, that is 36 minus 2 times 4 times 6 times cosine angle EAD. Right, so this is 52, right? So we have cosine angle EAD equals 2. Right, so cosine angle EAD equals 2. 27 by 48 equals 2. Nine by 16, right? That's cosine EAD. And to calculate the length of EF, we can still use cosine rule here. So EF squared equals 2 EC squared plus CF squared minus 2 EC times CF times cosine angle ECF, right? Because angle EAD equals to angle DCB, so cosine angle EAD equals to minus cosine angle ECF, right? That's a key point. So equals to EC squared, which is 3 plus 5, that's 8 squared, 64 plus CF squared. CF we already calculated as 8, so 64 minus 2 times EC, which is 8, times CF, which is 8, cosine angle ECF, right? So that's minus of cosine angle EAD. So here become plus times cosine angle EAD, which is 128 plus 128 times 9 by 16, right? So that is 128 plus 72, right? So that equals 2. $200, right? So EF equals 2, 10 times square root 2. That's a second solution. And when I prepare this problem, I was thinking, is there any way that we can avoid the cosine rule? Since it's lengthy, right? Can we really simplify this problem? I mean, just without using the cosine rule. So let's just look at the figure again. Because AB equals to AD, right? We already know that ABCD is a cyclic quadrilateral. So I'm going to talk about the solution 3, right? ABCD is a cyclic quadrilateral. So that angle ACD equals to angle ACB, right? If we find, so from CB, we find that CN equals to CD, which is also 3, right? And we connect AN. Because angle ACB equals to angle ACD, and CN equals to CD, and AC equals to AC, so we know that triangle ACD and triangle ACN are congruent, right? Which means AN equals to 6. And we know that the length of BN equals to 9. So we can calculate the height, the altitude, right? I mean the height from the length from A to BC. Let's call this point as H, which equals to let me see if I can. Okay, let me write here. So AH squared equals to AH squared equals to AN squared minus HN squared. AN squared minus hn square, right, equals to 6 square minus. So what is hn? That's half, because an equals to ad equals to ab. So we know that triangle ABN is an isosceles triangle, which means h is a midpoint of bn, right? So hn equals to 9 by 2, right? 2 square. So it equals to 144 by 4 minus 81 by 4, which equals to 63 by 4, right? That's a square, an square. And we already know the length of HC because HN equals to 4.5, NC equals to 3, so HC equals to 7.5, right? Then we can calculate AC square equals to AH square plus HC square equals to 63 by 4 plus HC. We said HC equals to 7.5, right? So that's 15 by 2, and square of it, that's 225 by 4. So it equals to 88288 by 4, right? Which is 72, right? That means AC equals to 6 square 2. Right, we calculate AC by this way. AC equals to 6 square 2. And because we already, in the first solution, we already calculated the length of AE, AD, DF, CF. We know that triangle ADC is similar to triangle FDE, and we know that AC is in parallel with EF. So we can just use the ratio to calculate the EF. That's EF equals to AC times BF to BC equals to 10 square 2, right? This is just a way that we avoid using cosine rule. Okay, I think this problem is pretty interesting, especially when I figured out this point. It's very useful because when we, if you look at this figure, if you want to draw it just by rule and compass, it's kind of difficult, right? And only if you figure out that you can, because this n, you find this n point, and then you can draw the same circle to find a. I just leave this to the audience to try to just figure out how to draw A, B, C, D using the rule and compass. Okay, that's it. I hope you like this video. See you in next one. Thank you.